Star 10. We have a question. What is the pH of the solution just after the equivalence point when 21 milliliters of 0.1 molar sodium hydroxide has been added to 20 milliliters of 0.1 molar hydrochloric acid? We're on this purple section then at 21. It's somewhere up here. Okay, they had to make it so that we couldn't just read it off of here. We're supposed to calculate it. What do we know about this? We know that all of the hydrochloric acid has been neutralized by the sodium hydroxide that was added. Okay, that's a good thing to know. We know what the total volume is because we had started with the 20 milliliters of hydrochloric acid and we've added 21 milliliters of the sodium hydroxide. So the total volume is going to be 41 milliliters. And because I know what's happening next, I'm going to turn that into liters. Since these are the same, I mean, we can just sit here and figure out how many moles there are, right? Because this was molarity, that's moles per liter. All right, I can figure that out. I can figure out how much of everything was used up. Oh, okay, I don't really care about the stuff that's used up. I want to know what was left over, right? This was 20 milliliters at 0.1. When 20 milliliters of 0.1 has been added, that's when we were at the equivalence point. That means what wasn't used up at the equivalence point is 1 milliliter of the 0.1 molar. 1 milliliter times the 0.1 molar, which is moles per liter. Oh yeah, we're gonna have to do something about that because what's a liter? It's 1,000 milliliters, right? There we go. Now we'll have all our units squared away and we'll be able to figure out how many moles were used. When we do this, we're gonna come up with 1 times 10 to the negative 4 moles of OH minus. So concentration of OH minus is molarity. I know the number of moles. It's 1.00 times 10 to the negative 4 moles. And I know the volume. So divided by this, that will be my molarity. When I do that, run it through the calculator. There's my molarity, 3 sig figs. From that, I can get the POH because that's going to be minus the logarithm of this molarity, right? Run that through the computer and I get a POH of 2.61. Did they ask for POH? No, they asked for pH. So pH is 14.00 minus the POH, and I'm going to end up with 11.39 as the answer to this question, and that falls right in there, star 11. Okay, it says, what is the pH at the midpoint of the titration with a strong base of an aqueous solution sample that contains an unknown concentration of benzoic acid? Oh, I mean, I can go and say benzoic acid. Hey Siri, what's benzoic acid, right? C6H5COOH and water in equilibrium with hydronium ions and the C6H. Oops, that's not an H. I got ahead of myself. H5, COO minus, right? If I go look this up, I will find out the Ka for the benzoic acid is 6.25 times 10 to the negative 5th. I know that when I am at the midpoint, that I should have the same pH as the pKa. So all I really want to do is say, what's the negative logarithm of Ka? And when I do that, I'm going to find out that it's 4.20. So the pH in the midpoint should be 4.20. And there you see there's the midpoint. It's a 10 because this happened at 20. I look at 10 and I get, oh yeah, sure. Yeah, 4.20. I guess I can believe that. So the benzoic acid. Rules for monoprotic weak acid, pH should be the same as the pKa of the weak acid. You go and check table A 5.1 again, and you'll find the Ka, and it might have the pKa for all I know, but we can always find it from our formula if we need to.